Let it be two charges, minus q and plus q, separated by a small distance. Let it be 2a. So this arrangement is known as electric dipole. So basically, electric dipole, it is an arrangement of two equal charges, but opposite in nature. Separated by small distance. This arrangement is known as electric dipole. All right. Did you get it, Veeram?
Yeah.
Okay, fine. So electric dipole, basically it is an arrangement of two equal charges but opposite in nature, separated by a small distance. This is known as electric dipole. Now next is dipole moment. Now dipole moment is defined as, basically it is denoted by P. It is defined as the product of the magnitude of either of the charge by the separation between the charges. Fine. So it is defined as product of the of charge between the charges. Is it fine, Iram? Product of either of the charge magnitude by the separation.
Yeah.
It is a vector quantity. Direction from negative q to positive q. If it is dipole, the dipole moment will be from negative charge to positive charge. Now SI unit is coulomb meter. Ideal dipole. If 2a tends to 0, it means the separation is almost negligible. Then dipole is said to be ideal dipole. Dipole field, like electric field, dipole also creates its own electric field. That field is known as dipole field. So the electric field created by the
So,
yes,
so can you read the ideal dipole, please?
if 2a tends to 0, if 2a means the separation between the charges, if it is all means is negligible, then the dipole is said to be the ideal dipole. dipole field, the electric field created by an electric dipole. No derivations. Electric field due to an electric dipole at an axial point. Electric field due to an electric dipole at an axial point. Let it be, it is an electric dipole separation between the two charges is 2a. Let it be, if we have to calculate the electric field at point P, r is the distance from the center of the dipole. This is center of the dipole. Fine. So from negative charge, the distance will be r plus a, and it would be r minus a. Is it okay till here? If you have any doubt in figure, please let me know.
Yes, it's okay.
Now, due to positive charge, the electric field direction is away from it. And due to negative charge, the electric field is towards it. So it is an electric dipole. First of all, if this derivation comes in your exam, so first of all, you have to mention each and everything so precisely that consider an electric dipole separated by a small distance. R is the distance from the center of the dipole. Is it fine, Iram? Will you be able to do it in your exam, or shall I write everything?
I'll be able to do.
Okay. So first of all, electric field due to negative charge at P, E due to negative charge is 1 over epsilon Q over R plus A whole square towards just a minute. Sorry. Towards left. Likewise, electric field due to plus Q at point P. Towards right. Towards right. So net electric field at P, that is E axial, equals to E positive minus E negative, because electric field due to positive charge will be maximum because the charge is nearer to the point P. 1 over 4 epsilon Q over R minus A whole square minus 1 over plus Q over R plus A whole square. Iram, could you let me know the net direction? What is the net direction? Towards right or left? If I subtract the electric field, what would be the net direction of the electric field at point B, right or left, Iram? The electric field due to positive charge is bigger. So hence the direction of the electric field will be towards right. We can take out Q as common, Q over 4 epsilon. So R minus A whole square, R plus A whole square. Towards right. 4 epsilon. Okay. Till here done, Iram.
So just wait. I'm ready.
Sorry.
So few seconds. I'm writing.
So
Yeah, no.
now R minus if I subtract it, R plus A whole square minus R minus A whole square over R square minus A whole square. R square plus A square 2AR minus R square A square plus 2AR over R square A square whole square. Q over 4 epsilon AR R square A square whole square towards right. Till here, is it okay, Iram? Shall I move further or do you have any doubt?
You can move forward.
So Q into 2A times 2R 4 epsilon R square A square whole square towards right. So Q into 2A is P, so 2PR over 4 epsilon R square A square whole square. Because Q into 2A equals to P, that is dipole moment. So 1 over 4 epsilon 2PR over R square A square whole square. Now towards right. So net electric field at an axial point is towards right. Done, Iram. Shall I move further? E axial equals to 4 epsilon 2 p r square a square whole square towards right. Now, if r is much greater than a, that is short dipole, then electric field E axial equals to 1 over 4 epsilon 2 p r over r is to 4. So 1 over 4 epsilon 2 p r over r cube. Done.
Yeah.
So in vector form, if I write E axial equals to 1 over 4 epsilon 2p vector over r cube. Fine. Here, dipole moment is parallel to E axis. Note down. Iram, done.
Yes.
Do you have any doubt in this derivation? Or shall we?
No.
Okay, let's proceed. This derivation is very important. It usually comes in exam. Next is electric field due to an electric dipole at an torial point. let it be an electrodipole separated by a small distance. We have to calculate the electric field at point P at an equatorial point, is perpendicular from the dipole axis. The distance between the two charges is 2a. Let it be r. So it will be r square plus a square, again r square plus a square. Fine. Okay, then just let me know, due to this positive charge, what is the direction? Along BP or PV? What is the direction of electric field due to positive charge at point P? Along PV or BP?
Uh,
Positive charge, the electric field is always away from it. So along this direction. All right.
yeah.
And due to negative charge towards it, let it be make an angle theta. If it is theta, it would be theta. Theta. All right. Is it okay? Are you okay with this figure? If I resolve this
Yeah.
q, then there would be two components, E plus Q sine theta and E plus Q cos theta. Likewise, due to negative charge, E minus Q sine theta and E minus Q cos theta. Fine. Do you have any problem in this figure?
No.
Now, due to positive charge, so electric field due to plus Q charge at P equals to E plus Q 1 over 4 epsilon Q over under root R square plus A square whole square along P to V. Is it fine till here? Now, likewise, electric field due to negative charge, the magnitude will be same, but the direction will be changed. So along P to A. Is it okay, Iram?
Yeah.
Now here the perpendicular, because E plus Q and E minus Q, they are equal in magnitude, but so the perpendicular components E plus Q sine theta and E minus Q sine theta means the perpendicular of the electric field will be cancel out because they are equal in magnitude but opposite in direction. Here perpendicular components will be cancelled out. Hence, net field at equatorial at point P, E equatorial equals to 1 over 4 epsilon, just a minute, sorry. So E plus Q cos theta plus E minus Q cos theta. cos theta. So both are equal in magnitude. So we can write E plus Q cos theta plus E plus Q cos theta. Since E minus Q equals to E plus Q, both equal in magnitude. So we can write 2 times of E plus Q cos theta. Any doubt till here? Now, this is 1 over 4 epsilon Q over R square plus A square. Now, what is cos theta? Cos theta. Now, cos theta is base over hypotenuse. So, A over under root A square plus R square. Which is equal, cos theta is A over under root R square plus A square. Any doubt, Iram?
No.
So 1 over 4 epsilon Q into 2A, because I multiply this 2 by A, and this is R square plus A square raised to power 3 by 2. So Q into 2A is P R square plus A square raised to power 3 by 2. Fine. This is E equatorial. And the net direction towards left. Okay, Iram, shall I proceed?
Yes, sir. Let me just note it 1 minute. Yes, sir, you can.
No. If R is much greater than A, then E equatorial equals to 1 over 4 epsilon P over R cube. And in vector form, so look, the direction of electric field, the net direction of electric field is towards right, and the dipole moment is from negative to positive, means towards right. So the direction of electric field towards left and the direction of dipole moment is towards right, hence they are anti-parallel. So in vector form, we can write E equatorial is minus 1 over 4 epsilon P vector over R cube. Here, dipole moment for electric field E equatorial is anti-parallel to E vector, that is dipole. Okay, Iram.
Yeah.
Now relation between E equatorial and E axial for a short dipole. So E axial equals to 1 over 4 epsilon 2p over R cube for axial. And this is for equatorial is 1 over 4 epsilon p over r cube. These two relations is for short dipole. This is first, that would be second. Now first over second, first divided by second, you'll get E axial, E equatorial equals to 2. So we can write E axial is 2 times of E equatorial. Right. Done. Hiram, done.
Yeah.
This time. Give me a minute. Electric field due to an electric dipole at any general point. This derivation is not in CBSE. So this derivation is not in CBSE. Just this is a dipole axis. Make an angle theta. The dipole is towards this. We have to calculate the electric field at point P. Okay. So if we resolve the dipole moment, because dipole moment is a vector quantity, so this component will be P of cos theta. It would be P of sin theta. Now, due to this axial component, the electric field at point P would be, it would be even, and due to this component, perpendicular component, the electric field will be in this direction, and the electric field would be the resultant electric field of these two vectors. It will be E. So this is a dipole. This is a dipole making an angle theta with the dipole axis. We have to, if we resolve it, so this component will be P of cos theta. The component perpendicular to this will be P of sin theta. Now we have to calculate the electric field due to both of the components. So due to this, at point P will be axial component, and due to this, the electric field E2 is an equatorial electric field. So even is, what is even, since we have discussed the electric field is 2P. So instead of P, we can write P of cos theta over the distance is R cube. This is for short dipole. Just remember, for short dipole. and E2 will be 1 over 4 epsilon P of sine theta over R cube. Fine. If we have to calculate the electric field at point P, then we will take the resultant of both the fields. So it will come out, if you solve it, out P over 4 epsilon R cube under root 1 plus 3 cos square theta. This is the resultant electric field. Fine. This derivation is not in CBSE, but if you know this result, then if you forget the formula, you can easily derive it. Is it okay? Now, what did I do in this derivation? I just simply resolve the dipole moment in two components along the axial, that is P of cos theta, and perpendicular to the dipole axis, that is P of sin theta. R is the distance from the dipole. We have to calculate the electric field at point P. So due to P cos theta, there would be a electric field, means axial component. E1 is the axial component due to this electric field, and P sin theta, E2 is the equatorial component of the electric field due to P sin theta. I just put the formula that, since I told you the electric field due to axial point is 1 over 4 epsilon 2 P R cube. So you have to replace the P by P cos theta. Likewise, E2 1 over 4 epsilon P sin theta, means I replaced P dipole moment by P sin theta over R cube. Then I took the resultant of these two electric fields, and the calculated is P over 4 epsilon R cube under root 1 plus 3 cos square theta. Is it okay? Iram, is it okay with you?
Yeah.
Now, if I calculate tan alpha means the resulting electric field making within axial with the E1, that is tan alpha equals to E2 over E1. That is E2 is 1 over 4 epsilon 2p sin theta, sorry, p sin theta over R cube, 1 over 4 epsilon 2p sorry 2p cos theta over R cube. That is equals to 2p cos theta over R cube. R cube P will cancel out. 1 over 4 epsilon will cancel out. Remaining will be tan theta over. So tan alpha equals to tan theta over 2. This is the resultant. This is a required relation. Okay, Iram?
Yes.
last derivation. Torque on an electric dipole in uniform electric field. So let it be E is uniform electric field is uniform electric field plays an electric dipole minus q and plus q in uniform electric field, making an angle with the electric field. So it would be 2a sine theta. The force experienced by electric field. Okay, Eren, just let me know one thing. If I place a positive charge in electric field, what is the direction of the force on it? Towards right or left? I'm talking about this dipole.
Towards left.
Towards right. Just remember, if I place a positive charge in electric field, the direction will be along the electric field. Okay.
Oh yeah.
And if I place a negative charge in electric field, then the direction will be
Left.
left. Now, so force on plus Q equals to plus QE. That is towards right. Force on minus Q QE towards left. Is it okay till here? Just remember, Iram, if I place a negative charge in electric field, then it experiences a force in the opposite direction of the electric field. And if I place a positive charge, then in the same direction of it. Is it okay?
Yeah.
So net force equals to minus QE plus QE. That is equals to 0. Negative sign indicates the direction. So net force experienced by an electric dipole in uniform electric field is 0. Now torque. Torque equals to force into perpendicular distance. Force equals to QE into perpendicular distance is 2a sine theta. So Q into 2a sine theta, that is PE sine theta. This is the torque, because hence P equals to Q into 2a. Is it okay, Iram?
Yes.
in vector form. Torque equals to P cross E. Fine. And just remember, torque is perpendicular to dipole moment and torque is perpendicular to electric field. Now, special cases. If theta is 0 degree, that is dipole moment is parallel to electric field. So torque equals to PE sine 0 and sine 0 is 0. So torque is 0. So when the dipole moment is parallel to the electric field, the torque experienced when electric dipole is 0. Okay, Iram. Second is if theta is 180 degree, that is when dipole is anti-parallel to electric field. So torque equals to PE sine 180 and sine 180 is 0. So torque is 0 again. If theta is 90 degree, that is dipole is perpendicular to electric field. Fine. So torque equals to PE, that is maximum, because sine 90 is 1. Okay, Iram. What about the assignment? Have you completed the assignment?
Few of questions are right.
Okay. Open your assignment, force on a charged particle. This one. Electric dipole in uniform electric field. This question I told you, this one. Now, electric field. Try first question. An electric dipole placed in non-uniform. Leave this question. I'll let you know next time. Okay, third one. Just go through it. Will you be able to do it? Which formula we have to use? An electric dipole when 30 degree with uniform electric field. The electric field is given, experiences a torque, calculate the dipole moment. Which formula we have to use it?
PE sine theta.
Do at home using homework. Okay, this question just do it at home. Okay. What is dipole moment, Hiram? What is dipole moment, Hiram?
Product of magnitude of the charges by the separation between charges.
What is the formula for it? What is the formula for it? Formula for dipole moment, Iram.
1 by 4 pi epsilon naught p r square plus a square.
I didn't get it. Please. I didn't get it. Okay, write down in chat box. Fast. Write down in chat box. Iram, write the formula in chat box of dipole moment. Am I audible to you?
So can you hear me? I said 1 by 4 pi epsilon naught 2 pi upon r square minus e square.
What is the formula for dipole moment? What is the formula for dipole moment? E sin theta. Okay.
That is torque, right? Torque on an electric.
Okay.
It's the same.
I didn't get it. What did you say? Could you
No, so you said that dipole moment formula is p sin theta, but that was also for a torque, right?
dipole moment equals to, sorry, P equals to Q into 2A.
Oh, okay. Yeah.
And what is an electric field due to a dipole at an equatorial point for a short dipole? Formula. Electric field due to an electric dipole at an equatorial point.